Hi guys, how are you all doing? So yesterday we take a look at Euclid's division lemma, fundamental theorem of arithmetic, LCM and HCF, and I left you guys with one question. So today we're gonna pick from that question. Then most probably what we're gonna do today is we're gonna take a look at exercise 1.1. Then we will try to prove if you remember, I have told you that root 2, root 3, pi and exponential are irrational number, but I didn't give you the reason for it, and I told you that I prove them later in the videos. So today we're gonna prove that root 2, root 3 are irrational by proper mathematical proof. And again, if time allows it, then we will also take a look at 1.2 exercise. So let me just start. Let me jump to the candle. So here it is, the last question. This was the last question. Okay, I have to change the color here. This was the last question. LCM of E and B multiplied by HCF of A and B is actually equals to A multiplied by B. So we have to prove it, right? First of all, let me tell you that the answer is this statement is true. Then the answer is yes, the statement is true. Now I'm going to prove exactly why it is true. So let's just take a look. Suppose, let me take an example. Let us take, let's say 25 and 50. So LCM of 25. First of all, I will write 25 is prime factorization. So it is 5 multiplied by 5. That simply means 5 square. 15 as expression of prime factorization can be written as 3 multiplied by 5. So I can simply write it as 3 to the power 1, 5 to the power 1, and this can be written as 3 to the power 0, because 3 to the power, any natural number to the power 0 is going to be 1, multiplied by 5 to the power 2. So now, when I have to find the LCM of 25 and 15, it is what? What is LCM? LCM is basically all the primes with their lowest power, right? So here prime are only 3 and 5. So 3 multiplied by 5. Here the power of 3 are 0 and 1 respectively, and the power of 5 are 2 and 1. In LCM I have to find the lowest power, so I'm going to take 0, and lowest among 2 and 1 is going to be 1. So this is equals to 1 multiplied by 5, that is 5. And the HCF of 25 and 15 is going to be prime with their greatest power, right? So the greatest power here among 0 and 1 is 1, and the greatest power among 2 and 1 is 2. So this is exactly equals to 3 to the power 3 multiplied by 25, which is going to be, I think, 3 5s are 15, 3 2 are 6 and 7, 75. Now the LCM is 5 and the HCF is 75. This is equals to 5 5s are 25, 5 7s are 35, 36, 37, 375, and the product of two numbers, that is 15 multiplied by 25. So 15 5s are 125, 5, then 12, 25 ones are 25, 25 plus 12 is going to be 37. Because right hand side of both the equation is true, both the equalities are true, therefore 5 multiplied by 75 is equal to 25 multiplied by 50. So we have taken a simple example and we have verified that this statement do holds true when A is equal to 25 and B equals to 15. But this is a specific case where we have taken a specific value of A and B. just to get the idea that whether they are actually being, the statement is actually holds or not. But if I have to prove it for a general case, like if I just say A and B are two natural numbers and I can't take specifically what A will be or what B will be, then how will I be able to prove? I will take the idea from this example. So let us just say, okay, the page has ended here. Let me just start on the new page. Let me change the color. Okay, so let us just say that A, the prime factorization of A is A1, A2, A3, I don't know, but suppose AM. Now obviously this A1, A2 are prime numbers. They can be same too, right? They don't have to be distinct prime numbers. They can be same too, but obviously they are prime numbers. Suppose prime factorization of B is B1, B2 multiplied by B3 and goes on to Bn. Now when I take LCM, okay, actually I can specify, I don't need to take A1, A2. I can specify the prime numbers. See, A1, A2, A3 or M or B1, B2 has are prime numbers, right? And we know what are prime numbers. So instead of writing A1, A2, I will simply write the prime numbers. Suppose prime factorization of A is 2. The first prime number is going to be 2. 2 to the power A1. Then 3 to the power A2. The next prime would be 5. Then 7. And then it will go on. Similarly, let the prime factorization of B is 2 to the power B1, 3 to the power B2, 5 to the power B3, 7 to the power B4, and then it will go on. Now obviously, these values A1, A2, A3 can also be 0, right? Like we have noticed in the previous example that when I'm writing where I'm writing LCM of 25 for 15. So I have written 3 to the power 0, right? Or in this case, when I'm writing prime factorization of 25, I have written 3 to the power 0, right? So this A1, A2, A3 can also be 0. There doesn't need to have a natural value. Now, if I multiply A and B, what I'm simply doing, if I'm multiplying left hand side, then I'm also multiplying right hand side. So right hand side would be what? 2 to the power A1 multiplied by 3 to the power A2 multiplied by 5 to the power A3, and in the same way whatever this is, we're going to product it with 2 to the power B1, 3 to the power B2, 5 to the power B3, and then it will go on, right? So because when we are multiplying numbers, and if the expression only contains multiplication, we can interchange the values, right? So instead of multiplying 2a1 with 3a2, I can simply multiply 2a1 with 2b1 first, right? And what I'm trying to say is that 2 multiplied by 3 multiplied by 4 is equals to 2 multiplied by 3 multiplied by 4, or this is also equals to 2 multiplied by 4 multiplied by 3. What I mean by that when I'm multiplying multiplying some terms, then the arrangement of numbers doesn't matter. I can multiply any two numbers first and then multiply their product with the remaining number, and it will give me the same resultant. So in the same way, I'm gonna get 2a1 multiplied by 2b1. I'm gonna product them first, then 3a2 multiplied by 3b2. I'm gonna product them, then 5a3 multiplied by 5b3, and in the same way we're gonna product the remaining prime with respect to their powers. So when I write 2 to the power, suppose p multiplied by 2 to the power 2, if base is same, the powers gets added, right? So this is equals to 2 to the power p plus q. This is basically one of the uh, if both of the bases are equal, then when we are multiplying the multiplying terms in the form of 2p and 2q, the power on them gets added. So here what I'm gonna get, 2 to the power a1 plus b1 multiplied by 3 to the power a2 plus b2 multiplied by 5 to the power u3 plus b3, and it will go on. Don't get confused of this. We can simply take an example. Right, 2 to the power 2 multiplied by 2 to the power 3. So I'm saying that this must be equal to 2 to the power 2 plus 3, right? Because base is equal. So 2 to the power 2 is going to be 4, 2 to the power 3 is going to be 8, and this will be 2 to the power 5. Now 2 ones are 2, 2 twos are 4, 2 is are 6. Sorry, 2 ones are 2, 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32. So this is gonna be 32, and 4 eights are 32. So both of these are equal, and if these are equal, then this has to be equal. So this statement, this I guess identity is true. So what we're gonna get here, that if I'm multiplying a and b, then I'm gonna get this 2 to the power a1 plus b1 multiplied by 3 to the power a2 plus b2 in the same way. And suppose I have to take the LCM of a and b. So see, the prime factorization of a is this, the prime factorization of b is this. When I'm taking LCM, what I'm taking prime numbers with their lowest power. So if there are only two choices, suppose, let me give you a simple example. Suppose you have a bag and the bag contains one orange and one apple. Now suppose I asked you to, without looking in the bag, just grab one of the object from the bag, and you grab it out, and when I ask you to open your hand and show me what you have grabbed, you open it, and it appears to be an orange. So if there were only two objects in the bag, orange and apple, and when you took one out, you got apple in your hand, or sorry, orange in your hand, then can you tell me what will remain in the bag? The obvious answer is apple, right? What I'm trying to say here is, if you have only two choices, and if you choose one of them, then the remaining one will be the other one, right? So if you have two choices and if you choose one, there is only one choice remains. So remember this simple observation, because we're gonna definitely use this in solving this relation. So this is prime factorization of A, this is prime factorization of B, and when I'm right LCM, I just simply take prime with the lowest power. So prime here are 2, 3, 5, and so on. Now suppose there are two choices, A1 and B1 here, right? A1 and B1 here. Now one of them has to be lower, and either both of them are equal, right? In that case, uh, the lowest power is also gonna be one of them, and the greatest power is also gonna be one of them, and they both are gonna be equal. But suppose they are not equal, then suppose if the lowest power is A1, then the greatest power is gonna be B1. When we find LCM, the greatest will be B1. And if the lowest power is B1, while solving for LCM, when we solve this same idea for HCF, the greatest power will be A1. What I'm trying to say here, that there are only two choices, A1 and B1, right? Either both of them are equal, or either one is less and other is greater. If there is an equality, if there is an inequality, then if I choose A1 during LCM, then I will have to choose B1 during HCF. Or if I choose B1 during LCM, then I will have to choose A1 during HCF. So it doesn't matter what I choose here. I can choose any one of them. I can choose, let's say, mm, let me choose A1. Here, let me choose B2. Here, let me choose, suppose, A3. So during HCF of A and B, because A1 is the lowest power, B1 has to be the greatest power. Because B2 is the lowest power, A2 has to be greatest power. If A3 is the lowest power, then B3 has to be the greatest power. So when I product both of the LCM and HCF, what I'm gonna get 2 to the power A1 multiplied by 3 to the power B2 multiplied by 5 to the power A3, and whatever this is, we will multiply this by 2 to the power B1, 3 to the power A2 multiplied by 5 to the power B3, and so on. Don't get confused why I have taken specifically A1 here, why I have taken B1 here. You could have, I'm just taking a general idea, that you could have taken B1 here. But if you have chosen B1 as the lowest power during an LCM, then during find calculating LCM, you have only one choice, A1, as the greatest power, right? So this is again because they are these are numbers and we are multiplying them with one another. So it doesn't matter which two numbers are product first. So I'm gonna write it like this: a1 multiplied by 2 to the power b1, then 3 to the power b2 multiplied by 3 to the power e2, then 5 to the power a3 multiplied by 5 to the power b3, and in the same manner the remaining primes with their respective powers. So this is again going to be 2 to the power a1 plus b1 because the base is same, multiplied by 3 to the power b2 plus e2 multiplied by 5 to the power a3 plus b3, and in the same manner we will go on. So if you look at it, this and this both are equal because the right hand side are equal. The left hand side, that is this and this, has to be equal. So we just prove that if we are taking LCM and HCF of two natural numbers, then the product of LCM and HCF is actually equals to the product of the two natural numbers. So this was a basic idea. Now you could also think of finding LCM and LCO three numbers. What we will simply do is we will write the prime factorization of all three numbers. Then during LCM, we will write down all the prime, and we will have now three choices. Among these three choices, we will select the lowest power and simply calculate it. And during HCF, we will write all the primes, and again we will have three powers to choose from. We will choose the greatest power. So even if the number of LCM or HCF has to be found over more than two numbers, we can simply apply the basic definition, and we will simply write them in prime factorization. Then we will simply write all of the primes. Then whatever the choices we have for those primes power, we're going to simply find the lowest or greatest respectively to the LCM and HCF. So um, I'm gonna jump to the question next. I think we have question next. Okay, where should I get it? Zodo. Okay, here it is. We have done the LCM and LCF. There is this question. Do we have another question? Yeah, we have another questions. Okay, let's just jump directly into exercise 1.1. The first question is, let me zoom it. Oh, I don't like this zoom, but okay, it will appear like it's a little less pixelated on the screen if it is zoomed out, so I'm just going to do it. Exercise 1.1. Express each number as a product of its prime factors. Okay, so we have to simply write all of this number as prime factorization. 140, 156, 3825, 505, then 7429. I will let 140 and 156 up to you. You can simply do it. Let's just do 1825. Okay, 1825. Let me just do 1825. So how would we find the prime factorization? Let's just simply write it down like this. Now because the ones digit end with 5, we can obviously divide this by 5. So if we divide with 5, what we're gonna get? 5 3s are 15. We will have 3 as a remainder. 3, then 2 will carry. The carry 2 will come on. So we will have 3 32. Then 5 6 are 30. So subtracting 30 got 32, and then 5 6 are 30, so subtracting 30 from 32 we're gonna get 2, and then 5 will carry, so we will have 25, and 5 5s are 25. Then again once digit end with 5, so we can divide again by 5. 5 6 are 30, subtracting 30 from 36 we're gonna get 6, and wait a minute, we could have simply done 65, sorry 35. What is wrong with me? 5 sevens are 35, so subtracting 35 from 36 we're gonna get 1, and 5 will carry, so we will have 15. 5 3s are 15, so 5 3s are 15. Then 73. Okay, so because last digit is 3, we can try 3. 3 2s are 6, 6 minus 7 1, 1 3, 13 doesn't come so in the table of 3. Okay, so not 3. 5 no, 6 no, 7 no, 7 nines are 63, 7 nines are 63, right? Okay, no, 8 no, 9 no, 9, I think 9 eights are 72, so no, 10 no, 11 no, 12 no, 13, 13, 13 ones are 13, 13 are 26, 13 are 39, 13 fours are 4 3s are 12, 52, 13 5s are 65, 13 6s are 6 8 3s are 18, 6 6 70, 78. So no. I think 73 is a prime number because there is no number that is dividing it. I don't think it is divisible by any number other than 1 and 30, 1 and 73 itself. So not 3, not 13, not 14, not 15, not 16, 17, 79 are not 18, not 19, 19, not 19, 20, 21. Yeah, so I think it is a prime number. So this is gonna be 7300. So when we have to write 1825 is a product of prime, so simply prime factorization of 1825, we're gonna simply take these numbers that we have calculated on this side. So it will be 5 multiplied by 5 multiplied by 73, that is equals to 5 square multiplied by 73. Let's jump to the next question. Okay, it was 3825. I think I took 1825. Is there a way I can simply just 505, 505? Okay, let me just find out what will be the prime factorization of 3825. Again, once digit have 5, so it will be divisible by 5, so it will be 3, 5 sevens are 35. So we will have 3 as a reminder. Then 2 will carry on to 32. 5 6 are 30. Then subtracting it, they will have 2. Carry will be 5, so 25. 5 5 are 25. And 5 1s are 5. Subtracting, we will get 2. Then carry will be 6. 6 26. 5 5s are 25. So remainder will be 1, and then carry will be 5. 5 3s are 15. Then 3 5s are 15. And then 3 1s are 3. Again 3 1s are 3. So remainder will be 2, carry will be 1, 21, 3 7s are 21. And then 17 1s are 17, because 17 is a prime number. So prime factorization of 3825 is gonna be 5. 5 multiplied by 5, so 5 square, multiplied by 3, multiplied by 3, so 3 square, and then 17. Then I think the next was 505, right? So let me just do 5005. Obviously, once digit have 5 in it, so 5 ones are, 5 zeros are, 5 zeros are, 5 ones are. Now what? If I took 3, 3 3s are 9, 1 0 3 3s are 9, 1 1, yeah, it won't work out. You know what? 11 9s are 99. Then I will have remainder 1. Then carry will be 1. So I will get 11. 11 ones are 11. Now 91 is not divisible by 3. Is it divisible by 7? It is. It is, right? So 7 ones are 7. I get 2 as a reminder. 1 will be carry. 21. 7 to the 21. Then 13 ones are 13. So the prime factorization of 5005 are 5 multiplied by 11 multiplied by 7 multiplied by 10. Obviously, writing this in this form is not wrong, but I will suggest that you arrange this number in increasing order. Obviously, arrangement doesn't matter, right? Because there is only, according to fundamental theorem of arithmetic, the every composite number has a unique prime factorization, or can be written as a product of primes in a unique way. If order doesn't matter, but it actually just helps you visualize. If in any case you are finding the LCM or HCF, it will actually help you. So let me jump to the next question. 7429. I think I will leave this 7429 to you. You have to simply do like the previous two questions. Find the LCM and HCF of the following pair of integral. Verify that LCM multiplied by HCF is product of two numbers. Okay. So let me just take one of this example. Let's just take this 336 and 54. Let's just take the question is, we have to find the LCM and HCF of 336 and 54, and then we have to verify that LCM multiplied by HCF is actually equals to product of two numbers. So first of all, we will write 336 as prime factorization. So let me find, because the ones digit is 6, I can Because it is an even number, so we can simply divide it by 2. 2 ones are, then 2 6 are, then 2 8s are, right? Then 2 8s are 16 and 2 4s are 8. Then 2 4s are, then 2 2s are, 2 2s are, 2 1s are, then 3 7s are, and then 7 1s are. So the prime factorization contains 1 2 3 4. 3 3 6 is 2 to the power 4. 1 2 3 4. Multiply by 3, multiply by 7. Let me find 54 now. Because once digit is 4, 4 is a prime number, we can easily divide it by, I think, 2. But 2 2s are 4, remainder will be 1, carry will be 4, so 14, 2 7s are 14. Then 3 9s are 27, 3 3s are 9, and 3 1s are 3. So we have 2 to the power 1 multiplied by 3 to the power 3 multiplied by 7 to the power 0. So LCM of both of this number is going to be what? Primes with their lowest power. So here the lowest power between 4 and 1 is 1, 1 and 3 is 1, and 1 and 0 is 0. So it will simply be equals to 2 multiplied by 3 multiplied by 1, which is equals to 6. Now let us take an example. Let us take a look on LCM. So LCM is simply what? Prime numbers with greatest of power. So greater power among 4 and 1 is gonna be 4, and among 1 and 3 is gonna be 3, among 0 and 1 equals to 1. You see, if I'm taking LCM and LCM among only two numbers, if I chosen one of them for the LCM, there's only one choice for the power of that prime number in HCF, and that would be the other one. See, if I have chosen 1, then there's only one choice, 4, among these two. If I have chosen 1, there's only one choice remaining for HCF, 3. If I have chosen 0, there is only one choice remaining for 1. So this is equals to 2 to the power 4 is 2 ones are 2, 2 twos are 4, 4 twos are 8, 8 twos are 16. 16 multiplied by 3 3s are 9, 9 3s are 27, and then 7 ones are 7. Okay, this is gonna be tough. So 27 multiplied by 16. 6 sevens are 42, 2, 4, 6 twos are 12, 12 plus 4, 16, 1 7 is 7, 1 twos are 2, 5 will get 2, 6 6 12 plus 1 13, 2 3 4, 4 3 2. Then I have to multiply. Okay, let me just rub it. 4 3 2, right? So it's gonna be 4 3 2 multiplied by 7. 7 twos are 14, 7 they are 21 plus 1 22, 7 fours are 28 plus 2 30. So this is gonna be 3 0 2 4. So I have to prove that. Okay, let me LCM multiply by HCF will simply be 6 multiplied by 3 0 2 4. It will be 6 4s are 24, 4, 2, 6 2s are 12, 12 plus 2, 14, 4 and 1, 6 0 are 0, carry 1, so 1, and 6 3s are 18. Now let me find the product of two numbers, that is 336 and 54. 4 6 are 24, 4 then 2, 4 3s are 12, 12 plus 2, 14, 1, 4 3s are 12 plus 1, 18. 5 6 are 30, 0 3, 5 3s are 15, 15 plus 3 18, 8 1, 5 3s are 15 plus 1, 16. So this is going to be 4, 4, 8, 11. So 6, 7, 8, and then 1. So this is LCM multiplied HCF is this, and this number is equals to 336 multiplied by 54, right? That means LCM multiplied by HCF is actually equals to the product of two numbers. Hence, we have verified it. Again, all of these questions are same. You have to simply find the LCM, HCF, multiply both of the result, and then multiply both of the numbers, and they will be, both of them will be equal. You simply have to verify. Find the LCM and LCF for the following integers by applying prime factorization method. So here we have three numbers. So let me just take one of them. I think this will be the easy one, because 29 is going to be prime number, 23 is going to be prime number, 17 is going to be prime number. So LCM is simply going to be 1, and HCF is going to be, multiply all of this. So let me just not take this. Again, prime factorization of LCM of all of this is going to be, wait a minute, LCM of, just wait a minute. Oh, I have caused a blunder here. I interchanged the definition of LCM and HCF. So while taking LCM, we have to take the greatest power, and while taking HCF, we have to take the lowest power. I recorded the whole two lectures and I didn't realize that I was committing a mistake. I'm really sorry that I taught you something I should have been very carefully um, looked into myself, looked into the material first. I should have looked into it. I think I just messed up the definition of LCM and LCF. As I have interchanged the definitions. So while finding LCM, you have to take the greatest power, and while finding the HCF, you have to take the lowest power. Oh man, there is no way I can go back and record all of this now. I'm really sorry, but I won't be recording all of this again. I was just so sure of it. I didn't even think twice about it. Okay, I made a blunder here. I really did. LCM, lowest common multiple, highest common factor. When I actually look back to the definition, like the full form of LCM and LCF, I just got this doubt that how can what the definition I'm teaching doesn't uh, sums up with the full form of LCM and HCF. And then I just realized that I have been teaching you the interchanged definition of both the LCM and LCF. Okay, so I'm gonna clear out the definition again, and then we will simply find out all of these questions. So the page is over. Let me change this to red. Let me write the definitions again. LCM, lowest common multiple, uh, write prime factorization, write prime numbers with greatest power. And while finding HCF, highest common factor, write prime number with lowest power. I'm really sorry I did that. I just got confused with this lowest term. I thought that because it has lowest in its name, then you have to take lowest power. But then when I actually realized that it is actually lowest common multiple, not factor, then I realized that I'm doing something wrong. And I just cross-checked it in the book and I just found out that I was wrong. I'm really sorry. So let me just make up for the mistake and we will just simply do this whole question. I'm not gonna give anything to you. Let me just do all of this by myself. 12, 15 and 21. So here is 12, here is 15 and 21. So prime factorization of 12, prime factorization of 12. So because once digit has 2 in it, it is an even number, so it will be divisible by 2. So 2 6 are, then because 6 is an even number, so it will be divisible by 2. So 2 3s are, and then 3 1s are. So 12 is simply 2 to the power 2 multiplied by 3. Let us write down 15. 15 is going to be 3 multiplied by 5, and 21 is going to be 3 multiplied by 7. Again, carefully observe that once I reach the state where I have written the composite number as a product of primes, I will simply stop. And to make sure that I'm comparing them easily, I'm gonna write all the primes I've gotten, which is 2, 3, 5, and 7. So it will be 2 to the power 2 multiplied by 3 to the power 1 multiplied by 5 to the power 0 multiplied by 7 to the power 0. Here I will get 2 to the power 0, 3 to the power 1, 5 to the power 1, and 7 to the power 0. Here 2 to the power 0, 3 to the power 1, 5 to the power 0, and then 7 to the power 1. So LCM would be what? Prime number with the greatest power. So here is prime number 2, 3, 5, 7. Now among this 2, 0 and 0, the greatest power is 2. Among this 1, 1 and 1, the greatest power is 1 because all of them are equal, right? Again, among 0, 1 and 0, the greatest power is 1. And among 0, 0 and 1, the greatest power is 1. So this is 4 multiplied by 3 5s are 15 multiplied by 7. 7 4s are 28. 28 multiplied by 15. 5 8s are 40. 5 2s are 10 plus 4 40. Time 2. This is 0 8 4 12. 2 3 plus 4. So it is going to be 420. Okay. Now the HCF would be prime numbers with their lowest power. So prime numbers are 2, 3, 5 and 7. The lowest power among 2, 0 and 0 is 0. Among 1, 1 and 1 is 1. Again, because all of them are equal, 0, 1, 0 is 0 and 0, 0, 1 is 0. So this is 1 multiplied by 3 multiplied by 1. So what I'm gonna get? 3. Now this will be the LCM of these three numbers and this will be the HCF of these three numbers. That was the question, right? Right. So let's just do the second one, 17, 23 and 29. I think, let me just simply tell you, LCM would be what? Prime numbers with their greatest power. Here, if you actually look carefully, 17, 23 and 29, all three of them are prime numbers. That simply means that prime factorization of 17 is going to be 17. Prime factorization of 23 is going to be 23. Prime factorization of 29 is going to be 29. So LCM will simply be 17 multiplied by 23 multiplied by 29. And HCF will simply be 1. Because the lowest power will be, like if I write it down like this, let me just explain. If I'm writing the prime factorization of 17, 17, 20 and 29 are will be the prime. So 17 can be written as 7 to the power 1, 23 to the power 0, plus 29 to the power 0. 23 can be written as 17 to the power 0, 23 to the power 1, and 29 to the power 0. And 29 can be written as 17 to the power 0, 23 to the power 0, and 29 to the power 1. So when I'm taking LCM, I have to take the greatest power. So the greatest power between 1 and 0 is going to be 1, 17. And the greatest power between 0 and 1 is again 1. And the greatest power again between 0 and 1 is. And LCF would be prime numbers with their lowest power. So among 0 and 1, lowest power is 0. So this is exactly equals to 1 and this is simply 17 multiplied by 23 multiplied by 29. Then we had 8, 9 and 25. So 8, 9 and 25. So even though they are not prime numbers, there is no factors common to them. What I'm trying to say here is that 8 can be written as 2 multiplied by 2 multiplied by 2. 9 can be written as 3 multiplied by 3. And 25 can be written as 5 multiplied by 5. So the primes here are 2, 3 and 5. So this can be written as 2 to the power 3, 3 to the power 0, 5 to the power 0. This can be written as 2 to the power 0, 3 to the power 2, and 5 to the power 0. This can be written as 2 to the power 0, 3 to the power 0, and 5 to the power 2. So while finding LCM, we have to write the prime numbers with their greatest power. Greatest power is 3, among 3 and 0, 3, among 2 and 0, 2, among 2 and 0, 2. And HCF would be prime numbers with their lowest power. So among 0 and 3, the lowest power is 0. Among 0 and 2, the lowest power is 0. Among 0 and 2, the lowest power is 0. So this is 1. This is 8 multiplied by 9 multiplied by 25. Now, let's just do this question. Given that HCF 306659 is equals to 9, find the LCM of 306 and 657. Okay, so the numbers are 306 and 657. I think its HCF is 9. 306 HCF is 9, मुझे LCM, I have to find the LCM. So HCF is 9. Now we simply know that LCM multiplied by HCF is product of two numbers, that is 60306 multiplied by 657. We have to find LCM. This is unknown, but this is known. So this is gonna be LCM multiplied by 9 equals 306 multiplied by 657. So what we're gonna simply do, we're gonna simply write LCM here, and this is multiplying here. If I divide both of the side by 9, I'm gonna get 1 here, 1 multiplied by LCM. LCM is again a natural number, so 1 multiplied by natural number is natural number, so LCM. And here, if I have to divide right hand side by 9, I will get something like this. Okay, so this is gonna be, this number is divisible by 3, this number is divisible by 3, this number will be 102, and here this will be 3. Again 3 ones are 3, 3s are 9, then remainder 1, 1 carry 2, 12, 3 4s are 12. Okay, this was 657. 657, 657, 657. So we have to simply do 657 multiplied by 34. 4 sevens are 28. 4 fives are 20 plus 2, 22. 4 6 are 24, 25 plus 26. 3 sevens are 21, 1, 2. 3 fives are 15, 16, 17, 7. And here we will have carry 1. 3 6 are 18 plus 1, 19. So this is 8. 2 plus 1, 3. 6 6 12 plus 1, 13. 9 plus 1, 10, 11 and 12. And this is 2. Okay, that is an interesting number. 2, 2, 3, 3, 8 will be the LCM. Okay, next question is check whether 6n can end with the digit 0 for any natural number n. Okay, so we have done one of the examples similar to this, that when we have to find out that whether a number will end with digit 0 or not. So if ever a number end with digit 0, it has to be a multiple of 10, right? So suppose 6n ends with digit 0, then 6n, I don't know what will be the multiple of it, but it should be a multiple of 10, where k is obviously a natural number. Now if 6n can be written as k multiplied by 10, 10 can be written as 2 multiplied by 5, because this side can be divided by 2 and 5, so this side must be also be divisible by 2 and 5. So let's just see that for n equals to 1, this will be 6, n equals to 2, it will be 36, for n equals to 3, it will be 36 multiplied by 6, I think it is going to be 216. In the same way it will go on. You will see a simple pattern here, that no matter what the value of n is, the number will always end with 6. And if the number is ending with 6, then this number can't be divisible by 5, because the only number that can be divisible by 5 are the ones which has 0 or 5 in their ones digit. So unless and until a number have 1, 5 or 0 in their ones digit, they can't be divisible by 5, right? So no matter what the value of n is, or n equals to 1 or 2 or 3, we can go on. The ones digit is always going to be 6, because it is not 0 or 5. Therefore this number will never be divisible by 5, and if it is not divisible by 5, then this equation doesn't hold, and if this doesn't hold, then this won't hold, and if this won't hold, then the number can't end with digit 0. Explain why 7 multiplied by 11 multiplied by 13 plus 13, and okay, these are composite numbers. So I have to explain why this and this are composite numbers. So if these are composite number, we have to simply find uh, more than two distinct factors, right? So let me find 7, 11, 13 plus 13. So one of the number is 7, 11, 13 plus 13. Now we don't actually have to multiply all of this and add all of this. We can simply just do this is one term, right? Because all of them are being product. So according to the BODMAS rule, we will simply multiply first, right? So if I multiply this and this, whatever I'm gonna get, let me just put it in a bracket to signify that whatever I'm gonna get after multiplying all of this number, then only the resultant will be added to 13. So this is gonna be a one term, a single term, and this another term. Because both of this has 13 as common, I can take 13 as common. If I take 13, multiple of 13 as common, if I take multiple of 13 as common, I will have 7 multiplied by 11 multiplied by 1 here. And because this is actually what? 13 only, and if I've taken multiple of 13 common from it, it will left 1 here. This is the simple property. If there are two numbers like this, a plus b, and if there is something common between them, suppose this was a multiplied by c plus b multiplied by c. This is one term, this is one term, simply because this is being multiplied and this is being multiplied. According to BODMAS rule, we have to multiply first, right, and then addition. So if both of the numbers have something in common, simply common factor, we can take the common factor common from them, and it will simply leave one at its place. So it will be a multiplied by 1 plus b multiplied by 1. So I will have c a plus b. Similarly, because this is being multiplied, so this will be a one single term, and then this will be another term. And because 13 is common factor of both of them, we can simply take 13 out of it. And if I take 13 common from it, it will leave one at its position, right? So 7 multiplied by 11 multiplied by 1. And here, because there is no other number other than 13, so it will simply leave 1 in its place. So it's gonna be 1. So this is 13 multiplied by 7 11s are 77 plus 1. So this is gonna be 78. Now I don't know what this number exactly will be. I can find out, but let us not do that rigorous method, because this number is 13 multiplied by 78. So 13 is a factor, and then 78 is a factor, and then 1 itself is a factor, and whatever this number is, it will also be its factor. That means it has more than two distinct factors other than one in itself. So this can't be a prime number. So and because it has more than two distinct factors, this is gonna be what? A composite number. So this number is gonna be a composite number. Similarly, can you see that this is all being multiplied? So this will be a single term and this will be another term. Because 5 is factor of both of this and this, we can take 5 as common. And then we will simply multiply this, or even if you don't multiply it, for example, okay, the page is ended. I have to add another page. So we had 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 plus 5. Because this is being multiplied, this is going to be one single term, then this is going to be another term. Because 5 is a factor here and 5 is a factor here, both of this term has 5 as its common factor, we can simply take 5 multiple of 5 common from them. So what we're gonna get here, 5, if I take common factor 5 out of it, it will leave 1 in its position. So it will be 7, 6, 1, 4, 3, 2, then 1, and here 1. I don't have to multiply all of this. Whatever this number is, 5 will be a factor of it, 1 will be a factor of it, and this whole number will also be a factor of it. So because it has more than two distinct factors, this number is going to be what? Composite number. So there is one more question. There is a circular path around a sports field. Okay. Sonia takes 18 minutes to drive one round on the field. Ravi takes 12 minutes for the same one round. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? 18 and 12, right? A circular path. Okay, so suppose this is the circular path and Sonia takes 18 minutes while Ravi takes 12 minutes. And suppose this is the starting point, they start from the same point, goes same point, same time, same direction, because there are two directions, this and this, but they're gonna take the same direction. So this is the starting point and they are going in the same direction. Suppose this is the direction. Okay, let us just go clockwise. They are going the same direction. I have to find out when will they meet again. Because Sonia is taking 18 minutes to complete the same path and Ravi is taking 12 minutes, so Ravi is obviously faster, right? So as soon as they start the race, Ravi will get ahead of her. When will they meet again? Suppose K is the time when they will meet again. When will they meet again? Okay, let us assume that K is the time when they will. I know what we actually have to do. We have to find either the LCM or HCF here. I'm just trying to form an equation. So if it is 18 and 12, what can I do? 12 and 18, right? Starting from the same point. This is gonna be 18, this is gonna be 12. This question is not that tough. Why I'm struggling with it? So 18 multiplied by key, 10 minutes. Ravi is taking 12 minutes. When will they meet again? The time when they will meet again. Come on, boy. Why I'm struggling with this? This is not a tough question. I know, right? This is not a tough question. Why I'm struggling with it? 18 and 12. The question is when will they meet again? When will they meet again? Suppose this is the time. It is asking me time, right? Time when they will meet again. So it is simply asking me time Suppose k is the time. Is it okay? Is it asking me the rounds? Suppose they both start at the same point at the same time. How many minutes? After how many minutes will they meet again at the starting point? Okay, they have to meet at the starting point, right? So they will start it from here and they will have to meet again here. Okay, I told you it was not a tough question. So they have to start from the starting point and they have to go in the same direction, and I have to find that how many times, how many minutes it will take for them to meet again at the same time. So they have to start from a starting point and they will have to reach the starting point. So let us simply say, let k, yeah, let after k minutes they meet again at starting point. I'm simply gonna assume that after k minutes they will meet again at the starting point. If that is true, then to cover one round, I forgot the name, but his took Sonia. Right? Sonia took 18 minutes and Ravi is taking 12 minutes. So 18 minutes, because 18 minutes equals to one round. Yeah, I could simply write it like this, that round covered in 18 minutes equals to one round. I'm talking about Sonia, right? Then round covered in 1 minute would be 1 by 18th round, right? Then round covered in k minutes would be 1 by 18 multiplied by k. So it will be k by 18 round. Now be very careful that this round after k minutes they meet again at the starting point. So suppose I start from the starting point. Then suppose I cover one round. So it will be one round. Then if I have to reach again at the starting point, it will be two rounds. Again, three rounds. What you are noticing is that if I'm starting from this point and completing my race, suppose to be race again at the starting point, I'm only covering rounds in natural numbers, right? So this can't be a fraction. This has to be a natural number. This has to be of the form 1, 2, 3, 4, 5, 6. It can't be a fraction like 2 by 3, 1 by 2, 1 by 4. This can't be true. That means if this has to be a whole number, suppose suppose k by 18 is a natural number, so let me just write it like this. 18 is actually a natural number. Let us say p. Then k is equals to what? P multiplied by 18. If I can write k as this, it means what? 18 is a factor. Similarly, if I do all of this for Ravi too, I'm gonna get that round covers in k minutes equals to 1 by 12. multiplied by k, which is gonna be k by 12. But again, Ravi has started from this point, and is completing the race at this point. So he will only cover round and natural numbers. That means k by 12 has to be natural number, let's say q. So if k by 12 is a natural number equals to q, that would simply imply this is the sign of implication not equals to. This means that this equation is implying this. So k equals to q multiplied by 12. If k can be written as q multiplied by 12, then 12 is a fact. And I have to find k when they will meet again. Okay. Now what? K is this, k is this. That means 12 and 18 are both factors of k. They are factors of k. If 12 and 18 both are factors of k, LCM is lowest common multiple. LCM is lowest common multiple, and HCF is highest common factor. So I have to find the LCM, right? I have to find the LCM, right? 12 and 18. If 12 is a factor of k, 18 is a factor of k, that means both are factors of k. Okay, let me just find the lowest common multiple of 12 and 18. So 12 can be written as 3 fours are, so it is equal to 2 square multiplied by 3. 18 can be written as 2 nines are, to 2 to the power 2 multiplied by 3 to the power 2. Right. So LCM will simply be prime numbers with their greatest power. So among 2 and 1, 2, among 1 and 2, 2. So it is gonna be 4 multiplied by 9, that is 36. Okay. So when I say that LCM of 12 and 18 is 36, it simply means that the lowest common multiple of 12 and 18 is 36. When I say lowest common multiple, what do I mean? First of all, let us understand what is a common multiple. Common multiple is the number which has 18 and 12 both as a factor. So when I say 36 is the lowest common multiple, you can easily see that 12 divides 36 and 18 divides 36. So common multiple simply means a number which is divisible by both of the corresponding number. In this case, 12 and 18. And when I say lowest common multiple, it means that the lowest number to do that, you can easily see that 36 multiplied by 2 is also divisible by 12. 36 multiplied by 2 is also divisible by 18. In the same manner, 36 multiplied by 3 is also divisible by 12, and 36 multiplied by 3 is also divisible by 18. In fact, any multiple of 36 is also divisible by 12 and 18. But when I find LCM, I have to find not these numbers, but I have to find the lowest number which has 12 and 18 both as a factor. So here when I found out that k has 12 and 18 both as a factor, I realize that if 12 and 18 both are factors of k, and if I find LCM of 12 and 18, that is 36, then the number has, whatever this number is k, the only way this is divisible by both 12 and 18. Basically 12 and 18, if they are factors, that means that 12 and 18 are dividing this number. So this number is divisible by 12 and 18 only and only if this number is either 36 or multiple of 36, like 36 multiplied by 2, 36 multiplied by 3, or 4, 5, 6. So whatever this number is, this has to be, this k is a multiple of 36. 36. Now the question actually asked me that when, how much, after how much minute they will meet again. So we have to simply find the first time they will meet. So multiple 36 are what? 36, 36 multiplied by 2, 36 multiplied by 3, and then we will go on. So the first time they will meet will be at 36, that is k equals to 36 minute. They will meet uh, they will meet for the first time. At every multiple of 36, that is 36 multiplied, they will also meet again after 36 multiplied by 2, that is 72. They will also meet after this time. So every multiple of 36, they will meet after that much amount of time, but the first time they will ever meet will be 36. So the question here simply requires you to realize that the if k is the minute after which they will meet again, k is such a number that 12 and 18 both are its factor. And if 12 and 18 both are its factor, that means 12 and 18 both are dividing the number. So if a number k is divisible by both 12 and 18, I simply found LCM. LCM gives me that the LCM of 12 and 18 is 36. That means the number which is divisible by 12 and 18 both, it has to be a multiple of 36. So I found out the k could be any of this multiple of 36, 36, 36 multiplied by 2, 36 multiplied by 3, but the first time they will ever meet will be this 36. So I guess that is all for today, and later on we will actually I have to introduce you to the irrational number, this property, but let me just do this again tomorrow because I think we are over time right now. So thank you for staying up to this mark, and please subscribe.